All right, let's go. Number 8, the Hubble Tension. The universe is expanding. We have known this for a century, but right now that expansion is threatening to break physics completely. To understand how the universe works, scientists need to measure exactly how fast it is stretching apart. They do this in 2 different ways. The first way is to look at the early universe, specifically the leftover radiation from the Big Bang, known as the cosmic microwave background. When they measure this ancient light, the math gives them a very specific speed. The universe is expanding at about 67 kilometers per second per megaparsec. But then there is the second way. Scientists can measure the modern, nearby universe by tracking the brightness of pulsating stars called Cepheid variables and the explosive flashes of supernovas. When they look at these relatively local objects, the math gives them a completely different answer, 73 kilometers per second per megaparsec. For years, astrophysicists assumed this was just a simple measuring error. They built better telescopes, they launched new satellites, they refined the math again and again, but the gap did not close. It got wider. The measurements became so incredibly precise that a mistake is no longer mathematically possible. Both measurements are completely correct, yet they violently disagree. This is the Hubble tension. It means that either our understanding of how the universe evolved is entirely wrong, or there is an undiscovered force of nature out there currently speeding up the cosmos in ways our standard models cannot predict. We are staring at a fundamental flaw in our understanding of reality, and no one knows how to fix it. Number 7. The Hercules Corona Borealis Great Wall. There is a fundamental rule in astrophysics called the Cosmological Principle. It is the absolute bedrock of how we understand the cosmos. The principle states that if you zoom out far enough, the universe should look like a smooth, uniform mist. Matter should be evenly distributed. There shouldn't be any massive, anomalous clumps of galaxies that dwarf everything else. Then we found the Hercules Corona Borealis Great Wall. This is a structure so incomprehensibly massive that it makes our Milky Way galaxy look like a single grain of sand in the Mojave Desert. It is a dense, violent cluster of billions of galaxies bound together, and it stretches across 10 billion light-years of space. To put that into perspective, if you strapped yourself onto a beam of light, the absolute speed limit of the universe, it would still take you 10 billion years just to cross from one end of this wall to the other. According to every established model of how the universe formed, this structure should not exist. There simply has not been enough time since the Big Bang for gravity to drag this much matter together into one localized space. The universe is about 13.8 billion years old. The math strictly dictates that structures this massive would require tens of billions of years to slowly clump together. Yet, there it is. A colossal, glowing scar slicing through the void, laughing at our textbooks. It proves that the universe is not a uniform soup, but a chaotic, deeply mysterious place, harboring structures that defy the laws of cosmic evolution. Number 6. Extremely early massive galaxies observed by JWST. When NASA launched the James Webb Space Telescope, the goal was simple. Point the most powerful mirror ever built into the deepest, darkest patches of space and look back in time. Because light takes billions of years to reach us, looking deep into space means looking into the deep past. Astronomers wanted to see the dawn of time. They expected to find the universe's babies, tiny, chaotic, messy little clumps of gas and stars just beginning to figure out how gravity works. Instead, they found monsters. JWST peered into the void, looking at a time just a few 100 million years after the Big Bang, and it saw fully formed, incredibly massive galaxies. Some of these galaxies contain as much mass as our modern-day Milky Way. They are packed with mature red stars, tightly structured and completely evolved. This is the equivalent of opening the door to a hospital nursery and finding a fully grown, 6-foot-tall adult sitting in one of the cribs. It is logically and physically impossible, based on everything we know about how long it takes for stars to ignite and galaxies to merge. Standard cosmology insists that the early universe was a dark, relatively empty place, and that galaxies had to build themselves slowly, piece by piece, over billions of years. These JWST galaxies shatter that timeline. They grew up way too fast. They hint that either our timeline of the Big Bang is wrong, or the forces of gravity and star formation worked at terrifying, hyper-accelerated speeds in the ancient universe. Number 5. Supermassive black holes at redshift greater than 7. Black holes are the ultimate cosmic traps. Born from the collapsing cores of dying stars, they start relatively small. To become supermassive, millions or billions of times the weight of our sun, they have to eat. They spend billions of years slowly gorging on surrounding gas, dust, and unlucky star systems. Physics even puts a strict speed limit on how fast a black hole can feed, known as the Eddington limit. If it eats too fast, the intense radiation from the heated matter pushes everything else away, cutting off its food supply. So how do we explain quasar J0313-1806? This is a supermassive black hole located at a redshift greater than 7, which means we are seeing it exactly as it existed just 670 million years after the Big Bang, and it weighs 1.6 billion times the mass of our sun. Based on the strict laws of physics and the Eddington limit, there is literally not enough time in the entire history of the universe for this black hole to have consumed enough matter to get that big. It is a mathematical impossibility. Even if a massive star collapsed into a black hole on the very first day the universe was born, and it fed at the absolute maximum speed limit without ever stopping, it still couldn't reach that size. Yet, there are dozens of these ancient behemoths lurking in the early darkness. How did they get there? Did the early universe somehow create supermassive black holes without stars ever being involved, collapsing giant clouds of primordial gas directly into the abyss? We have no idea. But these ancient monsters prove that the early universe played by a very different, far more violent set of rules. Number 4. The cosmic lithium abundance problem. Standard cosmology relies heavily on something called Big Bang nucleosynthesis. It is a deeply complex mathematical model that predicts exactly what happened in the first 3 minutes of creation. In those chaotic, boiling first moments, the universe acted like a giant nuclear reactor, forging the very first elements, hydrogen, helium, and a tiny bit of lithium. The math is incredibly specific. It tells us exactly what the ratio of these 3 elements should be. And for hydrogen and helium, the math is dead on. When we look out at the oldest, most ancient stars in the galaxy, the amounts of hydrogen and helium match our predictions flawlessly. It is one of the greatest triumphs of modern physics. But then there is lithium. According to the calculations, there should be a very specific amount of an isotope called lithium-7 floating around in these ancient stars. But when astronomers actually measure it, 2/3 of the lithium is just gone. It is entirely missing. This is not a slight miscalculation. It is a massive, gaping hole in our fundamental understanding of chemistry and physics. It is like following a precise recipe to bake a cake, putting all the ingredients in the oven, and pulling out a cake that somehow has no sugar. Where did the lithium go? Some physicists argue that the stars themselves somehow destroyed it in their cores, but the mechanics for that don't add up. Others suggest something far more sinister, that in the early days of the universe, mysterious, undiscovered dark matter particles interacted with the lithium and obliterated it. The building blocks of reality are missing, and we have absolutely no idea what erased the evidence. Number 3. The cold spot in the cosmic microwave background. When you look at the cosmic microwave background, you are looking at the afterglow of creation. It is a map of the oldest light in existence, captured from when the universe was just 380,000 years old. For the most part, it looks exactly like physicists predicted, a smooth, uniform ocean of radiation, with only microscopic fluctuations in temperature. But down in the southern hemisphere of this cosmic map, there is a giant, glaring anomaly. It is called the cold spot. This is an unimaginably vast region of space, spanning over 1 billion light-years across, that is bizarrely and unusually freezing cold. It drops in temperature far beyond what standard cosmological models allow. According to the math that governs the Big Bang, a temperature drop this severe over an area this massive simply cannot happen by random chance. The odds of a structure like this forming organically in the early universe are incredibly close to zero. So, what is it? Some scientists believe it might be an absolutely massive supervoid, a terrifying expanse of pure nothingness, completely empty of stars, galaxies, and dark matter, stretching for 1 billion light-years. But even that is hard to explain with current physics. Other astrophysicists have proposed an idea so wild it sounds like science fiction. The cold spot is a bruise. It is the gravitational scar left behind when a completely separate parallel universe bumped into our own during the violent inflationary period of the early cosmos. The standard models simply cannot explain it. The cold spot just sits there in the data, a chilling reminder that our universe might be much stranger and much less isolated than we ever dared to imagine. Number 2. Unexpected galaxy rotation curves. This is the anomaly that shattered physics and started the hunt for the biggest ghost in the cosmos. In the 1970s, an astronomer named Vera Rubin started measuring how galaxies spin. Now, according to the strict laws of Newtonian gravity, a galaxy should act exactly like our solar system. The planets closest to the sun orbit the fastest, and the ones far out on the edges move incredibly slowly. The same logic should apply to galaxies. The dense, incredibly heavy core of the galaxy should whip the inner stars around at blazing speeds, while the stars out on the fragile edges should slowly, lazily drift along. But when Rubin looked at the data, the universe refused to cooperate. The stars at the extreme edges of the galaxies were orbiting just as fast as the stars near the core. They were moving at impossible speeds. Based on the visible mass of the galaxy, the stars, the gas, the dust we can actually see, there was nowhere near enough gravity to hold those outer stars in place. The galaxies should have instantly ripped themselves apart, flinging billions of stars out into the dead vacuum of intergalactic space like cosmic shrapnel. But they didn't. They held together perfectly. To keep these galaxies from tearing apart, there has to be an invisible, undetected mass surrounding them. A massive, phantom halo of cosmic glue pulling on the stars and keeping them locked in orbit. We call it dark matter. It makes up 85% of all the matter in the universe, and we have absolutely no idea what it is. We can't see it, we can't touch it, and it doesn't interact with light. Our standard models can only account for 15% of the reality we live in. The rest is completely hidden in the dark. Number 1. Large-scale quasar group structures. Quasars are the brightest, most violent objects in the universe. They are the blazing, hyperactive cores of distant galaxies, powered by supermassive black holes that are furiously devouring unimaginable amounts of gas and dust. They are so incredibly bright that they outshine entire galaxies. Standard cosmology dictates that these brilliant cosmic beacons should be scattered randomly and evenly throughout the vastness of space. But just like the Hercules Borealis Great Wall, the universe refused to play by the rules. Astronomers discovered the Huge Large Quasar Group, or Huge LQG. This is a cluster of 73 massive quasars grouped together, stretching across 4 billion light-years of space. It is a chain of terrifyingly bright, supermassive black holes that completely defies the laws of physics. Once again, this breaks the cosmological principle. According to our core understanding of physics, no structure in the universe should be larger than 1.2 billion light-years across. The math simply does not allow for gravity to build anything larger than that limit. But the huge LQG is more than 3 times that size. The existence of these massive quasar groups suggests that the foundation of modern astrophysics is built on a flaw. Our models assume the universe is predictable, homogeneous, and uniform. But as we look deeper into the void, the universe is proving to be anything but uniform. It is heavily structured, deeply mysterious, and capable of building immense, impossible architectures that we cannot even begin to explain. These structures are not just anomalies, they are screaming warnings that the standard model of cosmology is cracking, and that the universe still hides terrifying, massive secrets we are nowhere near understanding.